Problem 16.24. In this problem, an aluminum pan whose thermal conductivity is 237 watts meter Kelvin has a flat bottom with a diameter of 15 centimeters and a thickness of 0.4 centimeters. Heat is transferred steadily to the boiling water in the pan through its bottom at a rate of 1400 watts. If the inner surface of the bottom of the pan is at 105 Celsius, we would like to determine the temperature of the outer surface at the bottom of the pan. In this problem, the mode of heat transfer that we have is going to be conduction. So we simply have a flat plate which has a temperature of T2 here, T1 here, and we have a conduction going in between these 2 points. We could write the amount of conduction to be equal to K, A, T2 minus T1 divided by L, and L is simply the distance between the two plates. The cross-sectional area that we have is going to be a circle. So if you think about it, this is more like a pan like this with a certain thickness. This is basically how it looks. Once again, this is at T2 and this is at T1. Okay, so the cross-sectional area is going to be a circle. So it's pi over 4 diameter square. Okay, if we calculate this surface area, it gives us 0.0177 meters square. We're going to solve this equation for T2, which is the outer surface temperature that we're looking for. That is simply going to be Q conduction times the length divided by Ka plus T1, and that is equal to the temperature T2. Okay, now let's substitute the values. So we have 1400 watts. The distance in between is going to be 0.4 times 10 to the negative 2 meters. The value of K is 237 watts MK. The cross-sectional area is 0.0177 meters square. And the inner temperature is going to be 105 Celsius. And so this is T2. If we plug it into our calculator, the value of T2 gives us 106.33 Celsius. Now if we compare the two values, notice that the inner temperature is 105, this is 106. That temperature makes sense since that surface is closer to the source of the heat.